way we grow and produce food is ever-changing, shaped by consumers and the climate in which we live and farm. Research at all points of our food system is essential for continuously improving food's journey from farm to table. The Manitoba Agriculture and Food Knowledge Exchange explores timely research innovations and applications that make our food system better than ever. Join us for today's podcast.
So I'm interested in how you got into, you call your lab a natural systems agriculture lab. How did you get into this whole natural systems thing? I mean, I presume that you didn't come out of your graduate degrees thinking that way.
Actually, I kind of did. I heard Wes Jackson when I was a graduate student at the University of Saskatchewan, and he gave a lecture on natural systems agriculture. I was absolutely captivated because I was always an environmentalist. I bought the Environmental Handbook, which was published in 1970 when I was a kid. I couldn't even understand half the stuff in there. And I did my early work on no-till and diversification of cropping systems and water use efficiency. So I was always interested in efficiency in terms of environmental constraints like drought and things like that. But then when you look at the trajectory of agriculture and think about all these pesticides that are going into the agroecosystem, like if we apply them one year or the next year, it's not a big deal, right? They're all registered. But the thought that we would apply them every year forever really worried me. I just don't think that's sustainable. We look at songbird numbers, we look at biodiversity has crashed in large part due to monoculture agriculture that uses pesticides. So that's always been a big motivator. Because I'd come from the no-till sort of community, I was also very aware that these farmers were doing a lot of great things in terms of their production system. I didn't want to just call myself an organic researcher because I felt that there were a number of ways of climbing this mountain of sustainability, and I still believe that to be true. And so that's where that natural systems agriculture handle came from. I basically stole it from Wes Jackson, so I'm going to be honest about that. But I've told him that, and he's been okay with that. But when you think about what those three words mean, we need to emphasize those nature's processes, and that's really the exciting part. And for me, organic agriculture forces us to try to exploit them in a practical way the most intensively. We're not always successful, but I think that's we've seen with the COP15 now. Conference that was held in Montreal, biodiversity is really important. And we're still learning about nature's processes. And I know from our research that organic agriculture makes a big contribution toward that. So, when we think about the movement of nature-based agriculture, we need to thank and congratulate our organic farming community because they've been real pioneers. They've paid the price to make these systems operational on the landscape. And so those are all so the fact that there's farmers doing this also motivates me to continue.
Okay. So you've talked about how organic has a role to play in increasing biodiversity. Do you feel that there's a similar role for mitigating climate change?
Yes, I do. And I believe one of the big roles is just to reduce the amount of fossil fuel that we need in our food system, need to create our food system. I think about a semi-trailer going down the road at 100 kilometers an hour. It needs a certain stopping distance. If you are running that same semi-trailer at 120 kilometers an hour, it needs much more than 20% more of a stopping distance. Organic agriculture for me is more like that semi-trailer that's working within the speed limits. It simply results in less risk. That's maybe not the perfect analogy, but the fact that fossil fuels, which are really at the heart of our climate crisis, requirements in organic agriculture are simply lower. And instead of using Haber-Bosch nitrogen, which takes a lot of pressure and energy and consumes about half the fossil fuel energy of our cropping systems, we use legumes, which take very little energy. They're natural, and they actually work. The other part of that equation is carbon sequestration, putting carbon back in soils. This is where maybe my no-till colleagues don't like the data, but we know that no-till in and of itself does not sequester any carbon. It just changes the position of that carbon to a layer in the surface. And so if you look at the whole profile, there's really not much net carbon increase. Carbon increases in soil come from plant diversity. and especially diverse root systems. That is now what we know from scientific research all over the world, including in Canada, some long-term studies that have really defined this. And so that's where organic agriculture has a role to play as well, as long as we keep those organic systems diverse and with diverse plant species, and we emphasize having living plants on the fields as much as possible in every growing season.
So, how does organic address the critics that worry about too much soil disturbance and suggest that that's the biggest issue in greenhouse gas emissions?
The place where I would point those critics, I would say, first of all, that's a really important question that you've asked, because if we overtill and have black summer fallow all year, I completely agree with them. That's really it's irresponsible land management. There is this process in soils called carbon use efficiency, and it measures the fraction of the carbon going into the soil that's actually converted into soil organic matter. And carbon use efficiency is something that people are measuring now. And we know, for example, Cynthia Kallenbach's work, she's at McGill University. She's done some very good work to show the higher carbon use efficiency in organic systems. And the reason for that is greater diversity of soil microbes. And so I'm hoping in the future we'll actually have a quick soil test that we can measure carbon use efficiency so farmers can design their systems to maximize that. In Cynthia's work, what was striking, and we actually found the same thing at Glenlee, is that even though the organic system put less carbon back into the soil, the efficiency of the which that carbon was captured was actually greater in the organic versus the conventional system. And that's something that takes a while to get your head wrapped around. Tony Vine at the University of Guelph showed this back in the 80s that, in the long-term study in the Laura, he said, plant diversity is more important than no-till in sequestering carbon. And that ruffled a lot of feathers. And we now understand how that can be possible. Now, no-till with a diversified crop rotation and cover crops is also an excellent system. The other criticism that organic farming gets is your yields are lower, so you're going to have to plow up more rainforest. Well, that's a bigger conversation, but I think it is one worth touching on. Thinking about how much grain we put into our gas tanks, how inefficiently we raise livestock. There's all kinds of efficiency in that bigger food system and that bigger energy system, which can easily overcome any yield reductions in organic agriculture. But getting back to the soil question, soil management, sustainable soil management is possible in organic production. We've proven it. We know it happens. It's also really important to educate farmers to help farmers discover for themselves what systems are going to allow those soils to be healthy. And that's an extension effort that I think we still need to work on.
Okay, so correct me if I'm wrong, but I came away with that thinking that diversity is even more important than tillage.
Yeah. Diversity, absolutely. And it's been proven. I could give you a long list of places that have proven that. The long-term Russell Ranch plots at the University of California have shown exactly the same thing. And it's not just plant diversity, but it's the diversity of the root systems. So sometimes, like my colleague Rob Golden here in the plant science department at the U of M is working on the question of how do leaving just a few weeds after harvest of canola help with soil health. And, he's discovering that they actually have a positive effect because it's the diverse root systems. And that makes a lot of sense because the microbes live in the soil right next to the roots. And so if they're getting a constant supply of diversity of root species from different plant species, they're much happier and their carbon use efficiency goes up.
Okay, thanks for that. Okay, we're down to my last question, which is you've been engaging farmers in the development of new crop varieties for a while. Is this avenue of research yielding valuable insights?
Yes, the program that we've been running has partnered with professional plant breeders where they create the diversity and then we've organized to bring those populations of wheat and oats and other crops onto organic farms where the farmers select them for a number of years. And then we evaluate how did the farmers do. I'm really happy to say that in the oat program, we have one farmer selected variety that is now going to be considered for formal registration as a variety in February at the registration meetings. And so that was a farmer in northern Alberta who selected that. Wouldn't it be awesome to have a farmer share in the royalties of a variety designed for organic production, because that's exactly what will happen. I think the participatory plant breeding program that we've done has produced lines that are maybe a bit better suited to organic agriculture, mostly because they're more competitive with weeds. Coincidentally, with wheat, plant breeders learned about 12 or so years ago that the semi-dwarf gene was actually linked to susceptibility to fusarium head blight. And now we're spending quite a bit of effort to try to uncouple this linkage, because farmers want short varieties, but these things are innately more susceptible. That was a little bit of an embarrassment for the plant breeding community, I have to say. Well, we were selecting tall varieties that whole time, and so we had some lines that farmers have selected that actually showed pretty good fusarium head blight tolerance in our variety trials. I would just end by saying I think I see this as a partnership, Laura, where if we have professional plant breeders who really understand the genetics and can select the right parents, for them then to make crosses, and organic farmers take those populations and select them, that's the best combination that I see, because it blends the best of Canadian plant breeding science with Canadian farming. And then, like I said, with that oat variety, some of them circle back and actually get considered as registered varieties. So it's a new idea. One of the features of the idea that attracts the funders is its lower cost. So it's really not why we set out to do it, but it turns out it's a cheaper way. Instead of having the research station maintain all these organic lands and train their technical staff to select for organic traits, why not just use invite the farmers to do that, because they have experience, although they do need to stay in contact with the breeder. So it's a great partnership. And it's not new around the world, it's new for Canada. The Dutch have been doing it with potato breeding for decades, and it's really paid off for them as well.
Okay, thank you. And thank you for giving me a bit of a glimpse into your world. And I just wanted to kind of end with, speaking of great partnerships, I just wanted to thank you for making my job easy as an extension specialist. It's very nice to have somebody that you can send questions to and who's actually leading the way in terms of solving the problems that the producers that I work with uncover every day. So thank you for that, Martin.
Thanks for those kind words, and enjoy the rest of the day.
Thanks.